Good morning, good afternoon, good evening, dependent on where you happen to be watching this screencast. We're looking at lesson number 4, and lesson number 4 is called Developing Code, Pseudocode. So welcome to you all, and let's make a start. And the first thing we're going to do is review the answers to the quiz that I set at the end of lesson 3. So let's have a look at that. So here are questions. The first question is it faster to process real numbers or integer numbers? The answer is integer, because they are smaller than real numbers. Is the letter A a numeric data type? It's enclosed in quotation marks, so the answer is no. Is 22/7 a float? The answer is yes. What data type requires the most storage, real or integer? The answer is real, because real numbers are bigger than integer numbers. Is a mouse an output device? The answer is no, it is an input device. Is the number 3 a numeric data type? Yes, it is. Is -3 an integer? Yes. Is a USB drive an input device? Yes. Is 3.14 an integer data type? No, it's a float because it has a decimal point. Is breaking the problem down decomposition or abstraction? It is decomposition. Okay, yep, decomposition. Is identifying specific differences, decomposition or abstraction? The answer is abstraction. And if you remember lesson 1, we spoke in detail about decomposition and abstraction. So hopefully you would have watched that screencast, so you'd be very familiar with those two answers. Does data have meaning? No. Is 102.5 a real data type? Yes. Is a printer an output device? Yes. Does information have meaning? Yes. Is a keyboard an input device? Yes. What data type would be used to store the area of a circle? That would be a float, because it's more than likely it will have a decimal point. What data type would be used to store the number of students in a class? Integer, because that will be a whole number. Is A before B? That's probably a dummy question. Okay, so there we go. So those are the answers to the quiz that I set you in the last lesson. So hopefully you would have had a go at that in your own time. Just compare your answers with what I have there, and if you see any errors that you've made, be sure to correct them. Okay, so moving back to the current screencast. So we've reviewed the answer to the quiz from the last lesson, and now we're going to have a look at what we're doing in this screencast. So we're looking at pseudocode, and the question is, can you write pseudocode for your journey to school or work? Just have a think about that one. Let's move on. Okay, so we're talking about writing pseudocode. So what I'm going to do is go through writing pseudocode for finding the area of a number of simple shapes. So we're starting with a triangle. So it says create pseudocode, asking the user to enter dimensions for a triangle and then print its area. Okay, so if you have a go at that, feel free to pause the video at any time so that you can have a go at these exercises that I'm asking you to have a go at. So the answer is coming up on the next slide. Okay, so here we go. So in order to find the area of a triangle, We receive the base from the keyboard. We receive the height from the keyboard, and we create a variable called area, which contains the formula for calculating the area of a triangle, and we send that information to the display. So area of a circle. Again, the question is create pseudocode asking a user to enter dimensions for a circle and then print its area. So have a go at that, and the answer is coming up shortly. Okay, so here's the area of a circle. So we receive the radius from the keyboard, receive pi from the library, and again we create a variable called area, which contains a formula for calculating the area of a circle. Then we send the area to display. Moving on now to the perimeter of a rectangle. So it's the same process. So we want to be creating pseudocode to calculate the area, the perimeter rather, of a rectangle. So yet again, have a go at that, and the answer is coming up on the next slide. So here we go. We see the length from the keyboard, receive the height from the keyboard, and we create a variable called perimeter containing the formula for calculating the perimeter, and we send that result to the display. The next exercise is finding out the area of a square with an error message. So we're looking at creating pseudocode for the dimensions of a square, and then we're printing an error message if the dimensions are invalid. So yet again, have a go at that. So an obvious incorrect dimension would be if we had a length of -3. So here's a solution. Receive side from keyboard. If side is negative, send error to display, else send side by side to display. Then we end the if statement. Okay, so the next thing you need to do is install a valid copy of Python. So if you go to www.python.org and install the latest version of Python, and then you will have another exercise called Introduction to Python. And if I bring up the Introduction to Python, actually I'll probably commence that in the next screencast. So I'll just leave this here. So the most important thing is that you make sure that you've got a valid copy of Python installed on your PC. Right, so once you've completed the introduction to Python, which, as I said, I'll run through with you in the next screencast, you can write Python programs for the pseudocode from this presentation. So the area of the triangle, the perimeter of the square, etc. If you just have a go at creating Python programs, and that should enable you to gain a reasonable understanding of the fundamentals of Python. Okay, so that's the end of this screencast. So in this screencast we looked at creating pseudocode for various shapes, and I also asked you to install a copy of the latest version of Python and have a go at creating Python programs for the pseudocode. So thanks again for listening, and I'll see you again in the next screencast.